talk about the relevant background since some of this stuff is so new. And all right, I'm just getting things set up so we can continue. All right, here we are. Almost there. So click this button and there it is. So here we kind of have like our starting point. I guess before we continue, I also have like 2 other streams where we were working on this problem, and it requires a lot of background to really get into what exactly I was doing. So what I'll talk about right now is the actual execution of the artificial intelligence. And what we need to do first is create some of the data that we're going to give to the artificial intelligence. And although this may sound straightforward, this is a very involved process. And the model that we're using, Stable Diffusion XL, actually requires a specific dimension for the images. So there's some pre-processing and thinking about how to approach this problem. And we were able to create a payload, just like a zip file of the images in the correct formats. And from there, we are able to take the payload, the zip file, and put it into the environment where the AI is. For us, that's going to be Google Colab, but we can do this locally or what have you. We also delved really deep into the ethics and morals about artificial intelligence, and what we were able to do was read some of the licenses and official information from Stability AI. But you know, it's not necessarily an easy task to sift through all of the videos from before. I think there's like 3 hours. So everything that you're kind of listening to and seeing is unscripted. I'm hoping that people can appreciate the unscripted nature. You know, completely new browser tab and everything. So what we're at now is we were able to kind of create this payload in the right data structure, and so what we need to do is also now kind of deploy it. So a lot of times people will talk about continuous integration, continuous development, and a lot of tools exist, and GitHub is a implementation of Git version control. There's also GitLab, but I am in favor of both, just as long as you understand Git in general, the command line interface for it. I think that we can communicate well with each other in terms of CI/CD. So the repository that we're going to create is first JWST image to vid. All right, so just to kind of go back a few steps and talk about this payload. So yesterday we were working on this, and let me just see one thing. Yeah, we're good. All right, so this was like the notebook that we used to do our data collection, web scraping, and transformations of the imagery into the format that we are going to use. So at this point, I like notebooks because it kind of gives you a way to interact with Python in such a way where you don't have to create a entire shipped product for this. So you can see where I'm like sending commands and stuff like that, and we have like a list as a data structure with just like URLs, and that's okay. This is expected. It's supposed to be as easy to communicate as possible. That's the point. What I want to show everyone that is far more interesting than this is the images that we are going to create videos out of. And so that includes this. This is just like one of them. I'm not sure if I can parse like what exactly we are going to be looking at from the URL, but okay. It's from the JWST, James Webb Space Telescope. So, chameleon on molecular cloud. Okay, this is interesting. Cool. So this is an actual image from the JWST. So what we did was I kind of manually picked out the observations. There was no, so the kind of rule of thumb on a higher level was if I had like a telescope right now and I look through the eyepiece and the projection of that observation should be what I'm kind of putting into the generative AI model. So some of the JWST images have included information that makes it more of an infographic than an observation. So let's talk about the download options, and we were able to download them, and this means that each image, each pixel value has a physical representation of like the universe. And then we captured all this metadata, all this really great stuff like the instrument, when it was exposed, exposure dates. Sometimes I think these are exposed for longer than just like taking a look at an eyepiece. But anyway, we have all of that in the payload, and that is what I wanted to show people for now. But the other thing we can take a look at is a previous successful attempt to this, which was also done by me. So if we go to YouTube, our favorite website, I'm also using Ubuntu and Firefox, so I'm sure that YouTube is not throttling me at all. And okay, this is how I already get demonetized before I get started. Yes, thank you, recommendation engine, for recommending me this bit of comedy, late night comedy and music. And I'm trying to get to my previous export of this, which I uploaded on my channel. They were 4 seconds long, so it's, when I say video, image to video, it becomes like a huge asterisk. And you know, you get down to the point where it's like, okay, how many frames does that have? You know, seriously. So this is like cutting edge, 4 second long video that we have to run on a supercomputer, and also batch it together because of the crazy amount of carbon emissions. And here is one output from the space image. So we're gonna recreate this Jupiter image. So I'll just do Jupiter. Oops. So let's just look at like the before and after right here. Give me a second. Okay, so we got Jupiter. This is like the actual observation. It's like not moving, and it's not meant to be moving. Even after we create the video, it is more of like an animation is a better way of describing it. You know, we're really animating this still image. Right now, every pixel data, including this blank space here, might, you know, actually be, I don't know, like an alien hiding in there, like seriously. But when we create the data that's generated, none of that is reality. So, you know, what I mean is, like, if you have like an image, and then you apply like a filter to it, right? That no longer represents reality. So sometimes you can, sometimes you need to know like the exact, like to like the exact like pixel RGB value in order for it to, gain insights into some of these other things about it. But I can't go into too many details without really introducing a can of worms that I would have to try to explain. So, okay, we are heading to the before, and this is the after. Here we go. No, this is not. Excuse me. Okay, the video is a little bit more of a higher resolution, but we will generate the MP4. So maybe this is like our little sneak peek before we actually get to the nuts and bolts of this. Okay, so back to our repository, JWST image to vid. Python scripts to create, to download JWST observations and their associated data. So, you know, one of the things that you can kind of do in like a picture that you take on a phone is, take a look at all kinds of privacy concerns, like the lat and long of where this picture on your phone was taken. And there's a lot of other metadata associated with it, like which camera, exactly the aperture, ISO ratings. Some of these observations by James Webb do not have like these specific parameters that can be encoded in an image, like a PNG file or a TIFF or JPEG. Just because, how do you parameterize a space telescope like JWST? There might be ways to do it, but I chose JSON. So, and this includes like binary information, and I will be showing off the scripts and JSON metadata for it, but it provides like a more scientific way of doing processing of these observations. Of course, like your pipeline might not need it, but I think with a repository, it's good to provide that level of information. A README file. All right. I only have an hour, folks, and I'm already 20 minutes in. This is gonna take forever. All right. When I'm actually coding, a lot of this is silent. I think last night I just was like, didn't even say anything, and I got a lot done. I was actually able to debug some of the stuff. All right, take it for my word that we were able to recreate this payload from this notebook. But yeah, let me just download this notebook and then upload it to that repository so that you can do what we did. Add file, upload files. The CLI is preferred, but I would not be utilizing the visual nature of streaming if I use a CLI. So commit changes, add files via upload. Commit changes. But what if I don't want to commit on? Okay, so add notebook that creates payload compressed file with 50 characters. Alright, wow. Look who wants someone to commit, but also only 50 characters. All right, that's the best you're gonna get, folks. For me, this is very dry stuff. So, all right. People can now do this themselves. Actually, they can't, because this doesn't have like the notebook to create the AI itself. Okay. You know, I think I forgot to do one thing. I forgot to do. Forgot to see if I uploaded the payload. Let me just double check. Also, this is probably good. What about now? Cool. All right. Let's just so yesterday. Trying to get the data to your virtual machine or environment is sometimes not easy. None of this is sensitive information. Oh, actually. And the point is, like, we use the Google Collabs Google Drive integration. We tried to do some zip uploading and some more complicated things, but we'll continue that pattern. And if you want to know why, please reference the half an hour that I took try to figure that one out. Okay, so now we have to reference back to our other notebook, and we will be executing some stuff on a supercomputer. Yes. How do I define a supercomputer? Well, it's so expensive that it's super. Because any computational standard for a supercomputer is not consistent in time. Back in the day, YouTube is not receiving enough video to maintain smooth view streaming. That's unfortunate. I'm sorry if the stream is going to be a little bit less efficient, but this is a notebook where we do that. And so the supercomputer is oops. It's available here, and the main part about some of these AI technologies is being able to run on a GPU compute. So the GPU has benefits over the CPU, and that includes the ability to have like very quick VRAM, like available, and the parallelization and the multi-core abilities, where our CPUs usually have like 4 cores max, even the Threadripper has like 12 cores, but we need a lot of different cores, because each of these neural units ideally should have a core, but we sacrifice for thousands and millions of cores. And whatever I said recently made our stream connection excellent, so sending out the right algorithm keywords. Beware. I know the algorithm. Alright, so yeah, this person was able to really help me out. I tried to do this like manually myself, like just taking the neural weights of stability AIs, like AI, and just like trying to run that myself. I did spend a lot of time on it, and I learned a lot, but this person actually worked for Stability AI and was able to really make that process smoother for me. So thank you again. I think I changed around some of this stuff here, but I don't know exactly what I did. This is essentially just, yes. At the time of inference, all the setup is from this person, but at the time of inference, I changed it around so that we can optimize it for batch batch stuff. So I know we use Gradio. Yes, we use Gradio, but Gradio, I don't know if that's how you say it. I'm sorry. This is Python programming, and some of these libraries are not meant to be verbalized. So the point is, like, Gradio is a very great technology that has been around for less than a few years, and there are some features that are built for more mature technologies, like for batch processing, and I had to kind of build that in myself. Anyway, let's continue and run this code. Why am I so... Oh, you know why? Because we were connecting to this V100 instance. All right. You want? Let's just go on a fun tangent and let's see how much does a V100 GPU cost? GPUE. Okay. And the good part about some of Google Colab's environments are, they're already set up for you. All right. Yeah, so these are very expensive. I'm getting the 32 gigabyte one in the rental or whatever. So, oh gosh, 5.36 per hour. Okay, we got half an hour left in the stream, I think. And so we have like X amount of compute hours per month. This uses a lot, 5.36. So last time I did the calculation and took me half an hour of compute time, but that was like silent, no need to worry about any of the setup involved with streaming, and in a very ideal environment. So yeah, so I should have probably just run this before. Maybe I ran this a month ago, I think. Yes. So let's see. We are loading the model, the sampling function. That's where I really had a lot of problems with, but there is a lot of neat stuff in here, and I think that it opened every single little tiny variable that you see here. I could spend an hour to really talk about, to be honest, like even like why this is 1024 by 576. But this is where I had like a little bit more this is where I changed the code around. Oh, okay. So what I had done was I had in Gradio, you know how like you're inputting one image or one file at a time. It's a little bit involved to do multiple files at a time, and perhaps this is by design so that we're not sending over like hundreds of files at a time for a simple experiment where you don't know whether the output is going to be good. And maybe this is intended, but what I was able to do with Gradio was ask the user for a file path that contained the images, and it would process each image once. And yeah, that's kind of that edit here. So yesterday we talked a lot about creating an index. Basically, we spent a lot of like time and just energy thinking about this. One of the reasons why is because when we're creating or generating these AIs, what you'll find, and this is something that Midjourney does too, is they'll present, you know, multiple variations or runs of the same input and show you the result. We could get into some mathematical discussions about the stochastic nature or the deterministic nature of algorithms and why this might be necessary. But for our current our current exercise, we are also going to take a look at this best practice and implement it ourselves. We will, for every index, create 3 outputs, maybe 4, but for now 3, and we will choose among them later which is the best, or which is like, you know, the one that we will publish essentially. So you can see how, even though the index was, you know, as simple as a file name, once you have, like, you know, we had about 50 files, we're going to be creating some 50 videos, and each of them are from like different observations from the JWST. We're also including hurricane images. So and then you have 3, or well, actually we're going to create 150 images or videos, 150 4-second long videos, because at every index we will create 3 videos. So you can see how very quickly things can get mixed up. So if you're not organized in this way, you know, it can get very difficult. So all right, and the setup process is just like this. We are I know that like the PyTorch is essentially the main machine learning library that will really do a lot of the heavy lifting for us, but there's also the transformers library and things like that. So we will have to restart the session, and what we will do is, I know that this notebook, it was, when I created it, when I edited it, I was able to like try to contain all the setup in here. And this setup in this cell is what I would call like what I would call safe versus unsafe. Safe meaning if I run this again as many times, you know, it's supposed to like set it up, and if it's already set up, it's not going to mess up our setup. Sometimes if you run a setup command again, even if it's set up, it will just destroy something or make it not work. So it says that our setup has been completed, so we will restart the runtime. We could have restarted the session or the runtime in that button from that cell, but then we would have had to, you know, scroll back and forth. So instead, I will be restarting it manually, and this also, you'll see like on the side of each cell, there's like an incremental counter for each time you compute something. Send it off to the Python interpreter. I'm gonna run it again, and you'll see it'll be like, oh well, we actually have this requirement already satisfied. Why are you doing this, Ahmad? Why are you telling me to install things I have already installed? Okay, you're right. But I just want to be sure. I got 2 views. Yay. One of them is from my mom. Listen, 1 view, that's all we need. All right. Okay, so collab hack for SVD. When I had encountered this myself, I know what you're trying to do. When I had done this myself, there was another way I did it. It was more elegant. I don't remember it. But also, I realized that I probably don't care enough to change this from what it was originally, and then run the entire pipeline again, just to make sure that it was the same. So, what is happening here? Okay, so essentially, like when we run a notebook, what if we have like custom scripts, right? We're allowed to like import libraries like NumPy and Pandas and TensorFlow and PyTorch. But what if we created a Python script? You can copy and paste it, but if it's like sufficiently large, very long, what do you do? So this is, if you go down the rabbit hole of like that question, there's a solution, and this is a solution. I think we'll continue. So downloading the weights. All right, so this is where we get to some very interesting things. We are going to request some neural network weights. I'm just going to go ahead and run it and then talk about it. So the weights, what are they? Neural weights are very different from the neural architecture. They are 2 separate things. In architecture, a neural architecture is initially randomized. Not for 100% of the cases, but for our purposes, we will assume that, our initial weights for a neural network are randomized. And given an architecture, there are millions, billions, even more than that, trillions of randomized weights. Our training process goes and takes the data and fits all of those millions, trillions of weights to the data. And so the weights are our ability to our ability to communicate an exact neural network and replicate it like we're doing now. So we just downloaded the weights, and you need 2 things. You need the weights and you need the architecture. The architecture, what do I mean by the architecture? So this, it could, the architecture are different types of ways to build a neural network, and there are different paradigms where every problem is different and every data is different. So you're dealing with things like imagery data, which are non-trivially different from things like textual or tabular data. And you have things like the kernel and things like filtering kernels, and that are not necessary in tabular data, because in tabular data, every data point is represented by a vector or a constant, but in imagery data, a data point is represented by this like set of numerical data that's like, it's like if I wanted to talk about a data point for how tall I am, there's a integer inch that I can talk about. But if the data point is how do I look like, it'll have to be represented by an image. And if you get down into the rabbit hole, it's like a million different numbers. And each of those million different numbers is separated by three different numbers, RGB. So this is non-trivially different from tabular data. And there does exist general neural architectures that can accept both, but a lot of them already utilize some of the methods that we have created with neural architecture. So it is also non-trivially different to communicate neural architectures rather than a generic neural net. And these include layers. So stability, AI, and different types of neural architectures have mainly benefited from a set of layers that can be described as transformer layers, auto-encoding layers. But actually, stability AI is not necessarily the same as some of the other ones that we've used before, because it's a diffusive model. So some of these neural architectures are not the same. We won't go into some of the ways to design these different neural networks, but we would if our problem was not using a neural network for our payload, because some of these neural networks are like just only best described during training, not inference. So we're just going to talk about inference for now. And these things are different in terms of what we have learned from, stats models. All right. Hopefully my questions or that comment made sense to people. If you don't know what I'm talking about, that's okay. please message me and I'll try to explain it to you. I have like done, the building of neural networks from scratch, like talking about taking a look at every, like a tiny, tiny neuron. Each of these neural networks can have trillions of neurons, neural units. So designing the specific neuron, whether it's a LSTM unit, GRU unit, whether it's for vision, there's different vision neurons. And taking the math and understanding what that means, putting them into layers or sets of neurons, and then taking inputs and outputs. But a lot of this is carried over from stats. So like when I described the process of actually from scratch designing neural architectures, it's from the design of the neuron. Afterwards, you're really using statistical methods more than machine learning, and some of the innovations in specific neurons come from back propagation and the really great ability of eliminating the vanishing gradient problem, because deep learning is what really enabled a lot of these AIs, and without the ability to do the ability to do multiple layers stacked on top of each other, which was what creates the problem of the vanishing gradient, was a breakthrough. Okay. All right. Well. Okay, so we have our stuff set up here, and I'm gonna go ahead and trust that the sampling function is good. So all right, so over here we'll have I'm just gonna upload our payload. I'm gonna try doing the upload tool. Instead of the other one. The other one, which you talked about early in the stream, which was the Google Collab Drive share. That's not what it's called. Sorry, Google, but I think that would that might encounter some problems where, let's just say I do mount my shared drive onto the system, and I have no expectation of persistency in this environment, but that expectation is invalidated once I put the shared drive on this environment. So basically, if I randomly type RMRF star, I might accidentally do everything on my Google Drive. So this has happened to me before. You would not know. You would not believe. But it looks like it's working. Let's hope it does. yes, sometimes when you explain yourself, you're able to teach a lesson. And because most of these things I really wouldn't wish on my worst enemy. Like, what I would is like, just this stuff isn't. It's just a waste of time. Just a waste of time. If I deleted everything on my Google Drive or whatever, on my network drive, I'd be able to recover, but at what cost? Just time. All right, and I'm going to be taking a slight break where I'll be waiting for the upload to complete. Maybe grab some water. Yeah, so give me like 5 minutes. And all right, folks, I'll be right back. Thank you. I'm hoping that people can hear me now. Yes, yes, yes. All right, so I think I had a 6-minute break. Oh man, this happened before. But let me see if I can change things around. Let me see if I already uploaded it. So I have a little bit of some information on my drive that's not something I'm like too comfortable sharing on the stream. Just believe me that all I'm doing right now is on another window, going into Google Drive and basically uploading that index.zip into there. So this is kind of a bummer because every minute, those 5 minutes cost me some money, some compute units. Well, Google, it's great that you're charging me some compute units, but if I have any expectations of privacy, you are throttling me. So, what do you have to say for yourself about these compute units? I'm kidding. You don't have to explain yourself, Google. You're much more. You're worth much more than I am. So, I am hoping to do this quickly. New. Yeah, so technical issues and all, this is unscripted. So this is how I am in real life, people. Yes. But I usually don't like talk this much when I code, to be honest. I think that's probably the only difference. It's also a lot faster too, because to my imaginary audience, I do have to explain myself to you. So, but to encode the logic into language and then to narrate it is something that I'm not able to do in something like cutting edge like this, that was an algorithm that was released, what could be described as a few weeks ago. So, it says 2 minutes left for uploading one item. Give me the 2 minutes and I'm gonna grab a coffee. And thanks. apologize as I took 5 minutes of your time in addition, and I apologize for that. But I am back. Alright. So, what we got here? We got we got the thing uploaded, right? Yep. So I'm going to mount this here, mount drive. How do I have my coffee? I actually have a very nuanced opinion about this, but my decision making is mainly about how much time I got. And if I had, additional time, I'd probably grind the beans myself, get a nice roast, and then possibly make espresso manually. But I just got this from a Keurig. Single serve, recyclable, not very sustainable though. Sorry, I just have to go through how there's like two-factor authentication. This was a lot of many different warnings. So, I'm not surprised because this was not my first choice to mount my entire Google Drive to this environment, but it works. So what I'll do, since I do have the ability to take a look at the terminal, right? So this is a virtualized terminal. They don't actually give you the real root access. I can tell because of there's like a little bit of a lag, and sometimes the lag is more than some other times. And based on that, it fits with my experience of a similar system where there was a similar lag and also different lags at similar different points. So I know what you're trying to do, but it's okay. I'm not going to tell your secrets on the street. Alright, so what was I even nonsensing about? Alright, I'm trying to get that index.zip to a actual on my drive on this environment, not from the shared drive, because if I try to use that directory, I feel like that could make things. If I make a mistake on my Google Drive, it's something that I will have to recover from. If I delete a file in this environment, who cares? None of this is all set up from Google. I literally I don't know, like it does not make a difference to me. Um, a technical way of saying that is persistency, but all right. LS drive. Oh, just gonna use the copy command. So copy. Did it complete the index? Did it? I don't think so. I think you're a liar. Oops. Oh, also it gives me the this stuff. What if I do this? Okay, so it's 11 megabytes on disk, and it's 109 megabytes on my disk. So I'm just gonna assume that they're not the same. This one is not uploaded correctly. So I'm just gonna rm index. Actually, I'm not gonna do that because I don't like the pattern of just deleting files. I should really get into new patterns. Okay, so I'm gonna make another directory. I'm gonna call this workspace. cd workspace. Go into that directory. All right, now I'm gonna go try taking that index from my shared Google Drive into this directory. So, oops, no. So copy, and then the copy command is target destination, something like that. Anyway, I have to find out where the file is to copy first. So this is in drive and then my drive, and there should be an index.html in there. Index.zip. Yes, so there is. Okay, so it auto-completed for me. I'm going to specify period to mean the current directory. Enter. Yes, and we do have a index.zip here. I'm going to go see if it's like, 191. Did I mistake myself when I said 109? Honestly, this is not even like the supported way of like checking if the file is the same. I gotta look at like the file hash, but file hash is overkill for now. Is not the same. What about on my Google Drive? Because it's 198 something. Although these details are kind of annoying, to be honest, but the index is like so golden that you have to protect it, because if you don't, then you'll get disorganized, and then all this effort means nothing, because you will have the AI generate something and you barely know what the input is. When we go down into like actually generating some of this stuff down into the rabbit hole, you lose sight of what is what, and you are trying to smush data into the AI, and it's such an involved process that nothing else matters. Tunnel vision. But when you come out of that hole, like, you just sit around and there's like a bunch of files. And you're like, oh crap, what did I just do? And some of this stuff takes a long time. So, okay, you got the point. The point is, details matter. And especially with highly experimental technologies, details matter. Details matter a lot. I could show you. I was, as I'm ranting about how much details matter, I clicked on the index.zip and just to see what the file size is on the disk, on the drive, and it says details could not be loaded. It is indeed 190.5 capital M capital B. I'm going to stop freaking out over this, even though I should. Alright, I have the exact number of bytes. You know what? I'm not going to make it human readable if that's what you're asking. 11997599213. Ooh, someone's in trouble. You know what that means? Someone did not do their units correctly. Either it's Google or Ubuntu. I'm gonna file a complaint and see where that goes me. See where that gets me. Just kidding. All right, this is the exact same number of bytes, but when it's human readable format in the units of megabytes (MB), I am not getting the same results. Perhaps there is a discrepancy between megabytes and megabits, or what is defined as a byte. I will table that discussion because we have other fish to fry. And we got the index, folks. That's great. Onto our environment. It only took us, oh my god, like an hour. Yes. Usually this takes me 15 minutes, like the entire thing. But as if I've like done that like many times before. Okay. All right. So now we unzip it. Unzip index.zip, and then this directory. The syntax was unzip and then the file that you're unzipping. Seems like it created a directory of the compressed file name, and everything is in there. Great. So cd into the index file, and voila, you will see on disk some of the things that we generated. I'll use the word generated in a different context, but some of the things that we created yesterday with Python. Okay. All right. If I go into my workspace and an index, okay, so you'll see many different types of like files. Our process was manually filtering out the observations available through the JWST official website, creating a Python script to download the imagery data in a PNG or JPEG or TIFF file, then creating associated metadata with the observation details, including the instrument, the name of the observation, color information, and saving that into a JSON file of the same file name. So when I click on one of these, it'll show you a resized observation. So, for example, we'll see here like a image that is of the exact size 1024 by 576. Did I get that right? You see, we should be less hard on ChatGPT for not remembering. Oh, actually, I got that right. 576. Yes, 1024 by 576. This was not trivial because, as we can kind of visually see, this is a little more widescreen. So what if I have like an image that was square, right? We would, what we did, we had two options for square images that were not in the same aspect ratio. So what we could, the two options was zooming in to the image such that the aspect ratio, so you'd be cropping out some different parts of the image, or we could shrink it so that there is additional black space where there is discrepancy in the aspect ratio. So I chose the second one, where we're not zooming in, we are keeping the entire image, so you might see some letterboxing and what have you. But some images were of the correct aspect ratio, like this one, so you don't see any letterboxing. Let me show you one that will have. So this is loading our image created with Midjourney. Midjourney's aspect ratio is more square. Don't quote me on this. I think it's 4:3. But this is more like a 16:9 ratio. I don't know. I think so. But again, we could have zoomed in on this image to kind of fill it up, but I decided to just letterbox it. And then the heuristic was chosen because it was not known whether a zoom would remove pertinent visual cues from the image. So for example, in this square one, if I zoomed in, it would knock out these people on the bottom. That would be pertinent, visual cues, right? If it kind of squeezed out only the top over here, probably not that important. Okay, so that was a script that I just created. Some of you might be asking, did you use Generative AI to help you script some of this stuff? I will say that yes, but I will say that My search process included Google, DuckDuckGo, Stack Overflow, ChatGPT, and Copilot on GitHub. So I think that uh, a lot of these codes. Okay, which code then is more generated? You might ask. Um, there is one function I will say, and I will cite ChatGPT on that function. One function that I kind of didn't care about doing myself. And you know what that function was? I remember now. It was I asked ChatGPT to create a function where the input was the file name and the file name and the data, and it would just save a file with the data with the file name. And honestly, it was a bad function that I returned because it was like 100 lines long. Like, why do you need that much freaking code for in Python, especially? You, honestly, like most people could do that in 2 lines of code. Why did I even ask ChatGPT to ask for something so simple? Hold on, why? But it worked. So for small things like that, I want to also embrace that transparency, and I don't think it's a waste of time to talk about it because I think I've been fairly transparent about this process so far, and I wasn't able to take advantage of some of the Gen AI tools for code completion from Google Colab. So, I don't want to like belabor that concept, even though it does deserve its own like decades worth of analysis, but we don't have that much time. So do the run. Not yet. You know why? How many resources do we have? Okay, we got enough resources. Okay, so where was I going with all of this? When we resized it, that is like the exact dimensions of the image. It requires Gradio does do some resizing, but I have found that it's actually kind of bad, and it's unknown the behavior of the resizing. For example, like you don't know whether the scale is maintained. Some people could just make it distorted, and actually, I did find that the method that I made with the resizing that I just explained was a little bit better than if I had just checked the box on Gradio. So some of these things I can explain, but it would take me some time, and it wouldn't be fair to literally the thousands of other decisions that I had to make when designing this system. So I will leave it up to people to message me about. All right, so I'm just gonna click execute on this just to show people what it looks like. here. Something is not correct because I remember changing it to where I gave it a file path, and I see here, you can see, one second, I think is there a way to collapse? So I don't think it's doing this line here, which is, it says input image. Oh, you know what it was? Huh. Okay. Yes. So when I created the proof of concept of this, I do remember changing the interface of Gradient, which I talked about here, and it's not represented here, but if you do version control correctly, and you really should, is you can trace your steps very quickly. So I'm going to do that now by going into the version control and then finding the exact notebook output that I can reference. So I think what it was that this gradient was not of type image, it was of type input, and then it was different. So I will click stop. Now this was slightly different from what I expected, but okay. I was a little bit nervous about whether or not the code would render correctly on the web interface for GitHub, but as we can kind of take a look, it has. Well, that's very interesting, but I know that, so what I found out was it was the same code. It was not like a, I don't know, it wasn't like a fluke. Like I didn't hallucinate this. Okay, perhaps I did not upload it because I did not want Um, do not want this like kind of hack for Gradio to be reflected. I actually don't know what happened. I'm at like a loss, but I don't think this really matters that much, to be honest. What I'll do, because the thing is like all this is demo Q. So I'm looking at the code specifically, and when we talk about end-to-end, it's useful to trace it back from the user interface, which is this, the Gradio, and then figure out like what's being executed from there. So I see that, we have Gradio being so there's a function called infer. Oh, okay, so infer. I know if I ask Copilot this, it would give me the wrong answer because what I've found is that like Copilot, if it's like a sufficiently, or ChatGPT, a lot of LLMs, they've been like programmed, I don't know by who. If you ask it a complicated question, it will just say it's not possible, even though it is. And I'm not really sure why it's been doing that, but I really wish it wouldn't. Because anything is possible. Like, all of this is math. So to say something is not possible in computing is like kind of saying that, oh, I don't think 1 + 1 = 2. Like it really does boil down to that, in my opinion. Any question that you have, anything can be changed and accessed. The theoretical part of it, in abstract nature, everything can be done. There are restraints. Some of it is money, some of it is time, but it can be done. Anyway, 55% faster with Copilot. Yeah, for very trivial stuff, but perhaps I'm not even gonna try it because I've already done this before. So I already know this whole circle. I'm gonna go ask Copilot or ChatGPT, and it's gonna say some garbage, and then I'm gonna be like, why did you even do this? You knew this was gonna happen. Infer. We got seed. We got the output paths. Input path. All right, folks. Here's the solution. Basically, I was able to trace it back to infer, which is a function that is how do I say it doesn't actually do the inference. It doesn't infer anything. it more or less manages an inference. And it manages it by taking, this very long list of parameters, anything that you could imagine, and then, handling all of those parameters into the actual inference, which was done here in the sample. So what I'm going to do is I'm going to make, first of all, I'm going to go to the Generative official documentation. Generative official documentation. So what I'm looking for is a input that's not the image input. The input that I'm looking for is like a text input, a string input. And I'm going to give it that file directory where I have like the index, but change around the infer function. Again, that just manages it to find all the images in that directory and just start generating it one by one. But this also brings us a good point and a good exercise on essentially just finding out how to do our multiple runs. So before I talked about how like this is a stochastic algorithm, it's not deterministic, and how if we run a deterministic, I didn't say this, I said, I'll say this now, if we run a deterministic algorithm, for every input it will give us the same output, determinism. Stochastic is not, it will give us a distribution, and sometimes the distribution is completely random, a bell curve, there's Poisson curves, there's different types of ways to describe a distribution. And Midjourney is another example of a generative AI algorithm that utilizes stochastic methods, and their workflow provides you not one output, right? Because it's not deterministic. It provides you 4. And there are ways, how many outputs do you really need? This is an open question. I believe that we can use stats and theories like the binomial theorem and theories about the standard bell curve to give us like a approximation of how many we need. So I believe that to get into like a p-value of a standard p-value, right, of like 0.01, we will ideally want like 32 to 40 outputs if we want to be rigorous about it. 30 to 40, 32 to 40, at least 32. But because of the computing resources, it's expensive. It's there's a lot of carbon emissions with running these supercomputers. So 4 is good. 4 images is good because you can just put them together in a grid. We will be doing just 3. So for every image, there will be 3 videos. And from my experience, they have indeed not been the same. So, all right. So we can kind of go back and take a look at the ability to, just find that file path where our payload is. And on the left hand side we have radio inputs. So in the user interface, which is currently an image upload, we'll have a text box. Text box, or another kind of way to specify the directory that we want us to generate the videos for. So I just want to remind everyone that this is unscripted. You know, I am like in live, real time, doing problem solving, and I'm narrating my problem solving as well. So, you know, please, you know, understand that this is like cutting edge stuff, and this might not have like, the reason for this exercise is because of its, you know, new nature. It's not easy to, um, it's not easy to prepare something so structured like your regular YouTube videos. What I'm doing here is taking a look at the other types of inputs and components. This reminds me of other CSS frameworks like Bootstrap and Foundation, where they are able to compartmentalize their interfaces with, like, you know, with this way. So okay, there's a JSON. I'm just going to compare these two. But I'm almost positive that what was the solution before was the text box solution. Okay, so this is the demo. Okay, so this is exactly kind of, this will get our job done. We just type in the text box into the text box, like the file directory, and then it'll be able to find the images to generate the videos from. Let's see the JSON input type. I'm just going to scroll down or click demo and see what it will do. Okay, this is a little bit more involved. We have to prepare a file, but let's just do a text box, all right? So text box, all right, and initialization, use default values. So this is the class text box. The other class was image, but the code that's existing has some different patterns for declaring the inputs compared to like what's in that demo. So one example is that they abbreviated Gradio as GR. You know, you can see that here. But they also had like the label as a parameter that they defined, and then type. Anyway, I'm just gonna select this and do text box. Is all lowercase? Who cares? Actually, it is very important, because if it is all lowercase, or sorry, because it's like these variable names are case sensitive, so it could totally throw it off. Okay, so the parameter we're looking for is type. Okay, so type is between text, password, and email. So password, I think it would, you know, have like, it would hide the characters as you type them in. Email probably does like some email validation. As a programmer, that's really great. Email validation is something that, like, I'm not trying to take a string and do it myself. Okay. I am going to leave. Um, um, what I was going to say was I am going to leave this empty, but I will follow the pattern of explicitly declaring it. Dude, come on. What is this even like labeled as? Well, I don't know why you're like giving me this here. This is just blank space. How do I fix this? I'm just gonna pick. Yeah, I'm gonna delete this and see what happens. Dang it, nothing happened. Okay. Here's what I'm actually gonna do. What I'm gonna do is I'm going to take a bunch of the code here that is not relevant to like the markdown, to this generated thing on this pane. Put it into another code cell where I can edit it, without some of these formatting errors, formatting issues, and go from there. So it's in my clipboard. There it is. So okay, so over here. All right, now I can kind of, make it a little bit less annoying. Okay. So, text box, label, type, and this was text. Label, directory with images. I'm gonna make this default as false. How do I know that? I don't know that. I'm guessing it because I remember that this was default true, like checked. And then I see that this is true is just coincidentally the value for this parameter value. And looking at the documentation from before, I think I have a good way to guess that that will equal to false if I wanted it to be unchecked by default. And right now this will not work, but here's what I want it to do. So I'm just going to click run just to show people the Creatio thing. You know, one of the things about Generative that I'm like curious about how they fixed is how they're able to like host a web app inside Google Colab, because I actually was running into this problem. Okay, so we can see that it does indeed not default to a checked directory with images, and then we have, you know, I'll just type in that directory. All right, so that worked. Gives me a directory. Input path is the directory. So now what do we need to do? So now we need to go and give it every single image from a directory, and maybe we'll call output or sample here. So runs through all of them and just calls this set of steps for every single image. Great. So what I want to do is create like a I'm trying to think about how I can restructure this function. I can just put like a for loop and loop around every single image or every single file in the directory, and I am leaving that up to the input, which I think is actually the right way to go. Yeah, I think that's the right way to go. I'm just going to assume that the directory you're giving me has the image, has all images and only images that you want to be outputted. Let's see, I just want to see, so I know lister, os.lister provides like all of it in here, but what if I have like the specific directory, does it let me do that? So if I do content and then workspace and then index. Awesome. So great. So in this block of code, I'm just going to make sure OS is already imported, or I'm just going to make sure OS is imported, the library from Python, even though it might be imported above. Never hurts to import it twice. So here's what I'll do. I'm not going to change around this function too much because I feel like it's it's great the way it is. So what I'll do instead is change the function signature and then change and then make another method that has the old signature and just provide a wrapper for the new one. Okay. By signature, this is like just a way of saying like the function name. So I'm gonna do infer underscore image. Now this breaks the entire all the code because now there's not a infer function. But I am going to create another one that does have it. So these type hints are great. I actually don't like type hints. And if you like type hints, I think that's cool too. But I will, actually I'll keep the type hints for now. You know what? You win today. It says return, needs to return a string, so I'm just going to return success. I don't know, for now. Okay, so I'm just going to copy the signature one more time. I'm removing the type hints because I'm not defining it, I'm actually utilizing it. And the way to call them, in this case, what I'm trying to do would be the same as just removing the type hints. So now, basically, if I run the code as it is, it will do nothing else. Like it would, basically, I'm just calling the exact same function with the exact same inputs. But what I'm actually now trying to do is, okay, so I'm not gonna. Wait. I'm seeing which function or which parameter gets called first. So it says function infer and the inputs are here. So inputs is image. So this is the first parameter. It's sometimes people when they put image or when they declare a function, they can declare it multiple different ways. Some people just kind of do it by the order of the input, so that's fine. Some people actually explicitly define which parameter of the function is going to be what, and that's fine too. It's more clear. But in this case, it was just like the order. So here we have like the order here. So you see like image resize and frames on step C, decoding T. We will see like the same kind of pattern here. So and I say all that because it doesn't do the explicit defining of the parameter name. I'm going to change the parameter name to be more explicit about what we're doing. So I'm going to call this, instead of input path, I'm going to call this directory. So this is a little more clear about, you know, this is the actual directory of the images. So creates inference from the directory. Okay. Just like a little docstring. I know this is kind of redundant, but I might add a little bit later. So, all right. So now back to the os.lister. So now we can put in that directory name. And this will give us like those files, right? So every single file. So for input underscore image in, so I'm going to loop through every image. Right now, all it is a string. It's not the data inside the image. So we have like the string of the file name, and this is fine because our index is constructed in such a way where the index is referenced by file name. I'm just going to write a comment here so that, you know, loop through. It's a little bit newer of a keyboard, so what I'm about to say is like, you know, it's have a little bit more errors in my keystrokes because this is a little bit, each key is a little bit bigger, taller than I'm used to. So this is a full-size mechanical keyboard versus like a laptop. You know how like it's different. So anyway, loop through each image in. It's not actually each image, it's each file, because that level of management is up to the input directory, you know, that you put in. Loop through each file and create a so one of the things that I'll also talk about when it comes to the code generation by Copilot and ChatGPT is that for some reason it does a lot of try catches, and you know what, that does provide less you know, errors in your code, but it's actually kind of faking it because you know, if you try and then catch and then, you know, there's an error, you can just print the error and then it's actually not an error anymore. That's like a way that it can do without encountering errors, but when you're actually debugging, it makes it almost impossible to find the bug because, you know, you're not really using a try catch the way you're supposed to be, you know. So try catch is like the last ditch. And Python, the way it was designed, was supposed to be fail fast, right? Fail fast. So I'm not going to put any try catches here. I actually don't like that practice. And it saved me a lot of time in debugging. Okay, so now we're going to construct our input path now that we have the input image. So we have the directory. I'm actually going to use a functional string and essentially just create an F in front of the pay F for respects. That's how I remember it, but with a lowercase. So our first is, when we're giving it the full input path, of course we have to give it the root directory and input image. So one thing about this is, well, there's actually a lot of things that could go wrong here. So I'm like trying to think about how to explain this specific thing that has go wrong. I'm just assuming that there's no like weird soft links going on. I'm gonna take your word for it and hope that this is a directory I can go through and have access to read. So at the end of a directory, there needs to be a slash, right? But when you're creating the directory string, if the directory didn't have the slash at the end and you're just adding the file name, you're now like a malformed directory string because it doesn't include the slash, right? So the question is, how do you get away with that? Well, folks, did you know that if you add an additional slash, it doesn't actually change the behavior of where the directory is pointing to? Additional slashes, as far as I'm concerned, do not, in my experience, do not make a difference. So I will add a slash here, just in case, and then input image. Also just print like a little processing. Processing input path, okay. So that will do it. But we're not done. We are not done. We're almost done. Very close to being done. So we want to make sure that the output that is created is, matching with our index. So I'm not actually sure if that's the case here. So sample. Taking a look, I'm digging down into the rabbit hole essentially. So we got to the infer function. Let's go to the sample function. That's where like the real math and etc. is happening. So end to end, we're now like here at that stage. Okay, so we have like the sample function. Input path is actually optional, but you really should, since it will otherwise just generate like a little example for you. So output folder optional, content / output, outputs. Great. So I don't know whether that's defined in our sample function. Let's see. Sorry, when we call the sample function, and I'm not sure it's defined, and it is not. Alright, so So what I'll do is I'm going to add another I am going to add another input here. So it's going to be our output directory. But I'm just going to call it directory. You know what? I'm just going to add that to the end since it's so related to the input path. In fact, I'm going to make it the first one. So directory, str, just type in, it's a string, don't worry. Okay, so now we need to change that for that. Doesn't actually use the directory right now, but okay, which sample type hints? Thank you for this. Oh no, just output folder. Yes, there it is. Okay, so folder equals. So this is, I think I was talking about how you can call a function in different ways. This is another way of doing it, which is explicitly defining that parameter. Both have its advantages, and one of them is like one of the advantages of this way is being able to just throw in a parameter anywhere in this list of parameters without having to worry about what order you put it in. So I think that, those are the two main ways that I do it, depending on the use case. Okay, so output folder. Now I'm going to make this my directory where I got the images, but create a folder called outputs. That is where the outputs will go. So now, scrolling all the way up here, we have our output folder. Alright. Yeah, you can see how okay, so they didn't add the slash at the end. So if I were to talk about one of the files inside this directory, and I just append it or just add it at the end, it's gonna make it look like, like this, untitled one talk, like that. And then, should have had this. Should have this. Okay. Moving on. Alright, now we're just trying to make sure that the output, since we're indexing by file name, we gotta make sure the file output name is the same. I think it just increases I think it's 0, 1, 2, 3, something like that. Like 0.mp4, 1.mp4. Excuse me. Data type floating point 16. Ambitious. I think that's one reason why I was not using 16 floating point precision. I tried to do this myself. I was using floating point 8. Alright, write all paths, video path. Video path C. base count. Let's see. Okay, so I'm just gonna write a comment here so it's a little more clear. Name the outputs incrementally. And actually, we're not going to do that. We're going to name it after the input path. So come on, man. I don't need any of this anymore. I did this myself. The resizing. Yeah, I didn't even need any hand holding. Alright, enough. Okay, input path is still available, so I can deduce the file name from the input path, right? You believe me? Okay, so I'm gonna call another one called video name. Okay, so we have like input path. Yes. Cool. Okay. So now I'm gonna so when one of the things that I really like to do when I think about algorithms and kind of translating, you know, what I say into code or math is think about how I would do it personally. So problem is trying to get the file name from the full path of it. So one of the questions I would have is, okay, how would I do that myself? So you don't think, sometimes this opens up like how you think in general, as you never even realized you thought this way. But what we do, naturally speaking, is look at the end of the directory or full path to figure out the file name, right? It goes from like left to right. But also it's delimited by that like slash, right? So you know that it has to be like, you know, after that last slash, right? Even if the, you know, it's not really a file if it has a slash at the end. So it's like a directory. You know, and that kind of cue. So going to encode that piece of logic that we just said, where it needs to be at the end, but also delimited by the slash. So the way to do that in Python, you know, is first to delimit it, to take it out. So we do split. As our delimiter function. And what split does is it takes that string, it splits it up wherever, like let's just say a string is like a little rope, right? And input path, or split, takes that string and kind of cuts it at exactly where that character is in that string. And it doesn't leave the character, you're just kind of cutting it, and then, you know, once you cut it, it doesn't exist, let's just say. So then we have to take the last, it returns this in an array or list structure. So, you know, to look at the very last element of a list in Python, there are many ways to do this. I use negative indexing. I think negative indexing is not there in other programming languages, but it's intuitive for Python because in Python the memory management is not as, you know, it's kind of taking care of compared to C and Java. So the very last element is going to be -1. So that's one cool thing about negative indices. So we have that. There it is. There is a file name. There it is. But now we have like the file name of the image. Now we need to. We also have the extension. So at the end, whether it's a JPEG or a PNG, you know, we don't want that either. So what we'll do is also. What was I thinking? Okay, so what I'll do is split, again, delimit it by the period. Now, if our file name has an additional period, when we reconstruct it, it's not going to like maintain that. So unfortunately, that's okay. That's like that's not like it is like not common, but it does occur. So if it does occur in your code or for reference, what I would have done is reconstructed it with a join. So yeah, okay, and split this up, and oh, I'm gonna have to join it anyway. Oh well. So split it up at the end, and now I want everything but the end. So I can still use Python's indexing and use negative indexing. So everything but the last. So this is one way of doing it. And then you would have this is still an array structure. So now what we need to do is use join. Alright, I've done this many times before, so I am a little more confident than per se someone who is trying to do this stuff like by themselves. Other ways to do this is regular expressions and video file name. MP4. Alright. It's not it. That's not actually all. So I'm going to add another parameter in our sample function. Yeah, one of the things that really makes me nervous about about editing these cells is accidental typos when you're traversing the function. So usually I honestly do this in like just the command line like vim, right? So if I make an accidental change, I'd use in the command line like git diff, and tells me where it is. But here I can't do git diff. There's no straightforward way to know like the changes between the files. So okay, I was okay, so I'm gonna call this resamples. This is an int. And by default, its part is 1. So this person, whoever wrote this function, was able to use type hints, but I think what's even more important than type hints is docstring. So they're kind of using a docstring here. I wonder if number of frames decoded at a time, each knows VRAM. I'm just going to use the same pattern here, just because I am not knowledgeable about what I don't know, and it could be that a tool that I don't know about encodes the comments at the end of this into something useful. So, okay, number of times we output a we create an output for the same output. Okay. I'm going to backtrack a little bit. Again, this is an unscripted session. I don't believe that this is the right place to do resample. I think the function that manages sample should be able to resample it, but the intention of the sample function is to sample it once. And I think I would be like non-trivially changing like the intention of like this purpose or this function. So what I will do is write in some logic that if I call the same image if I sample the same image again, what happens to the last one? Or what? How do I rename it? What about the... What about like the index? Okay, what am I looking at? What I'm looking for is, yeah, here it is. Okay, so whoever wrote this code had this base count here, which what it just does is it counts the number of times a file pattern exists in a directory, and here we have like MP4. What I'll do is I'll do the same thing for the image input and increment it, based on that way. So I'll also add like So, Instead of file name, I'm just going to call it index. I think after I add the index or the base count to the file name, it's really not gonna, that variable is not really named correctly or clearly. So, oops. So what this will do is take a look at how many times this video index was created. And then I'm going to append like I'm going to create like another, it's just kind of might be a little bit weird for people, but I'm going to make it a dot. Actually, I'll make it an underscore. Underscore. Or dash. I'll just do dash. Okay. Alright, so that means that it will save every run of this video, of this input into the directory with like the with like the iteration count, base count here. So okay, that will work. And now we need to move on. So the resampling function is all we need. And then we can just kind of go from there. So oh yeah, one way of doing diff is using like a manual diff checker, but it's just easier to do git diff, right? But you can't do it on notebooks. Boy, oh, base. This is wrong. There it is. Video path. Okay. I'm going to add some print. I'm just going to add like some different context here. Saving output to oops. Okay. Should be good. Okay, sampling. This is fine. Now this is where we kind of manage it. Okay, we manage it here. Okay, so do that resample parameter here in our top level infer function. So resample int equals 1. So if they don't have it, it's like it's just gonna do it once, you know? Okay. So this will just give us like, you know, at what sample we're at. If it's just 1, it'll do, you know, in range resamples 1, so just do just once, but the sample index will still be 0. All right, and then there it is. I know that this is going to provide output paths. Okay, so output path 0. This is one string. Okay. What I'm gonna do is a results variable, and this is a list of outputs. And then just type in, it'll do it as a list. That's the output, right? So we return results. Okay. We get a result from here. I'm going to see if I can make this slightly more readable. Nope, it's not going to make a difference. Yeah. Okay. And then just do results append. Oh, you know what? I can make this a little easier. Yeah. Okay, so I can do results append, and then list comprehension. Oh wait, wouldn't it be extend? Yes. So append, whatever it is, it's just going to add it to the list. Extend takes in a list, and everything inside the list it will append. Yeah. Append is a little bit quicker. Extend is not, but it's more flexible. Because it's like a list of strings, don't think it really matters that much. Actually, I'm having second thoughts about this other way of doing it in a list comprehension because it's not going to be very readable. Also, not very efficient either, since I'll be using extend. So I'll just keep append and keep this for loop that is a little bit more readable than the list comprehension. And just append the result. I'll do processing sample and then add a total so I know like how many I'm doing. So the total is going to be might be a little bit confusing because it'll like just say sample 0 and then total 1. Tell you that. I'm going to do now, instead of total, I'm just going to make it into like a fraction, but then add 1 to the sample index for the, you know, since we start at 0. Okay. Alright, so that would be a good kind of log message. Log messages are very important for this kind of computing because you really want to have an understanding of like what you're really doing as you're computing this. So these are very good. Now another way of doing debugging is using PDB, the Python, you know, debugger built in. But because I've like kind of done this already, I'm gonna rely on this instead. Okay, so I'm just gonna add another print statement here. F and then say done, and then output, and then the string representation of this. Okay, so that's it. Alright, so now we're done with the Python code, hopefully. Actually, all of the Python code, hopefully. But we still need to get the right images. So you'll see like the resized ones have like the tag resize. So we need to copy over some of those. So let me see how to do that. We only want to like use the ones with the tag resize since it's already in the size that it needs. So I'm just trying to look at the help for our copy command, and usually it gives me like what it needs. Okay, so CP source directory. What if like I'm doing it recursively, copy directories recursively. I don't think I need to do that. Okay, so I'm going to make their pre-processed. So even though we did process them, actually, yeah, I'll just call them processed. because we did, like I was about to say, we did process them and we resized them. Make jar processed. Okay, so then we're gonna copy everything with a resized and then a star tag. Star just means like wild card, and that means anything or any string of anything. Processed. Let's see if that works. Yep, that did work. Great. So that's it. That's it, folks. Whoa, how long has that happened? Something wrong with my video, but I think it's related to the fact that it's been at it for 3 hours. So what I'll do is I'll turn it off. I'm actually going to be like running this finally, and then coming back when I'm ready to like take a little break. So while I wait for it to compute. All right. So I don't know whether people can view this public URL. Let's see if I can. I don't really care, but anyways. I gotta make sure that that directory actually has another directory called outputs too. So yeah, if I had like a try catch, then what it would have happened was it would have made the output, and then while it's saving, it would have been like, oh, can't find a way to save it, and then it won't save it, and then there would be no error. So you would have generated everything, but not have saved anything. If you have like a try catch that was misplaced in some way. Content, workspace, index, / processed / that's it. I'm going to cd into that directory really quick. I'm gonna make a directory called outputs. I think the sample code had it where if it didn't exist, that directory, it would create it, but I'm not actually sure about that. So it's one command, so I just did it. All right, so here we go. I'm gonna click run. Cannot unpack non-int object. Great. What did we do here? Oh, for sample index. Okay. So as you could see, we didn't do any of this code with code completion, Copilot. We just had some syntax highlighting, so some of the stuff that I didn't get caught until runtime. What was I doing? Sample size, that was not here. That was in the infer function. There it is. All right, so I thought we were unpacking, a tuple because of this comma. And if I run it again, actually I have to stop this. Let me run this. Oh. I already ran it because it was executed as 16 but I'll do it again and then run this. You know what? I realized I forgot to do the resampling function correctly. It said resamples. Okay. You know what? I'll make it into a little new Gradio thing. Okay, so we want to make it numbers. There it is, number. What's a demo? I just wanted to see the interface for this. Okay. Great. All right. My function name, sorry, my variable names can be a little longer, but I think it helps with readability. Output resamples equals gr.number. And I will follow the pattern for some of the other stuff here. Oh, yeah, my typing is a lot better usually, but I haven't had a stable keyboard to really practice on. So if I was on my laptop, I would have clacked away. Okay, so number of times to run again. No, because if I had 1, then I wouldn't be running again once, I'd be running again 0 times. Number of times to run on okay. What's the thing? Default value. Okay, we'll make the default value 1. All right, so now we go down here, and we have output. See, I didn't even use the variable completions. Oh, thank you. Yes, very helpful. After I have already typed it out correctly. Okay. So now it will pass in the output resamples to our infer function, which, okay, that makes sense. All right. Do the run. Oh, I only got the 16 gigabyte one. Whatever. Okay, so we're doing it 3 times each. Directory with images is going to be content slash workspace slash index slash processed. Alright, let's click run. Processing sample 1. As you can see, our RAM goes up. Each of these does not actually take that long, so what I'll do is I'll just show everyone like the output from this first one, and then we'll take a break. I'll leave the stream on for people wanting to know like how it's looking, but I'll be back. Okay, so one of the things that we can take a look at on the terminal is this process, this command NVIDIA -SMI. I think so. Yep. So this shows us like our GPU utilization. They did have like the graph, but that was provided in the resources tab, and this one gives us a similar similar thing, but a more snapshot of what's currently happening in a little more detail. So you can see that Tesla V100, and you can see some of the other things about it. Oh, did I think that there was another way of doing NVIDIA SMI so that it would continuously update. I forgot what it was though. Okay. Um, it's not that interesting, to be honest with you. Um, if I was able to show it to you, running like that, it will kind of reflect what we're just seeing here. Cool. On the left-hand side, we'll try to navigate to our outputs. So, okay, well, there is one output. Okay, so this is the output. I have to open it in my PC, but I'll share that with you in just a second. Okay, so let me just change the window to my VLC player. Take just a few moments. All right, so yeah, here it is. So that's one of our outputs. If I click on the other one, it'll kind of show you something similar. This is from like the deep web, or it looks like the deep web, but it's a different one. So yeah, and what we could also do is just join those three videos together and in kind of a loop, but I will take a look at some of the progress that we were making before. Hold on. so I'm just going to close the tabs to the right, even though there's a terminal. Alright, so things are going well. It's creating those 3 videos per. I will double check like the outputs in a terminal window. So go to the outputs. Thankfully, we were already in the directory of the process images. Go into the outputs. What's inside? Something not good. Seems like it's overwriting the next sample. So give us a second here, folks. I might have to redo this, redo the output before going forward. Yeah, I'm gonna stop the current run because it's not actually yeah, it's not actually doing what we want. All right, so I'm going to make it easier on myself and make this base count a input function to sample. Sorry, an input to sample. So alright, that means that when I do these outputs, I am going to have to remove all of them. And unfortunate. Anyway. Okay. But bucket. Okay. Since I changed that, I'm gonna have to rerun the cell, and then where I'm managing it, I have to put that into the sample index and kind of pass it along. I'm just going to make a sample index +1 just so that it's a little bit more readable. Sample index +1. And then change it in the infer signature. Sample index. It's an int, and it is equal to 1 by default. Okay, so now when it's something with base count equals sample index. Perfect. Did I do base count right? You know, instead of deleting that other code, I probably should have commented it out. Yeah, that's what I'm gonna do actually. That was a wrong. Is it? Okay. It is, but I'm not gonna undo it until I find it. I have another tab. So where was it? Okay, here it is, base count. Oh, I'm hungry. 3.5 hours, folks. We're almost done, though. Some of the last things are being run. So here I'm going to add that code back in again, but just as like a comment really. Alright. Cool. Do the run. They were like the zeroing out of some of the what was the code, bro? Okay, it was, I know it's on my GitHub. What I'm trying to do is manage some of the GPU memory, and there's a way of doing it. You don't need to do it with the way the code is set up right now. It's not necessary, but because we're kind of batch processing it, it's going to be useful. And I did this with something totally different. Not totally different. This was just for generating 3D stuff, and this was also a hell of a thing to figure out, but wasn't here. Was it 8 months ago? No, was it that long ago? Well, couldn't have been me, I don't think. When did I do this? This was 2 months ago, see? Okay. So what files did I add? Okay, this was in November 6th. It's in docs. All right. Almost there. Kind of the same way I do things, but this was all the way at the end. Yeah, there was like 1,000,000 epics or something like that. Not really. It's like a few thousand. Here it is. Export. Yep. Alright. This is it. This is like a little thing to add to something loading. Your session crashed. Oh no. That means we have to run some of these cells again, but if it's already set up, then it doesn't really matter. Okay, so I'll do this. What do we gotta do? Collab. And then we already downloaded the model. We do need to load the model. Sampling functions need to be defined. Okay. Alright, so whenever that's done, what did we come here for? Oh yeah. So this code to make it a little more efficient. Which one it's at. Let's see. There's an error. Not good, not good, not good. Yeah, because the okay, this I remember it doesn't download it if it's already exists. be spinning. Yeah, it does do the empty cache here. Interesting. Okay. Just the model architecture. Yeah, that transformer layer is a bunch. Yeah, it's just, I think it's just loading all that into the RAM. GPU RAM. Okay, perfect. So after it did run that code here, we did see a significant reduction in the RAM. So that was a valuable exercise. It dropped from 10 gigabytes to 5. So um, I'm gonna increase this a little bit. So I'm gonna make it 30 frames. And increase it to 34, 35. See what happens. I'm gonna make it 1 frame at a time. Okay. Okay, so no such file or directory, totally fine. That's because it doesn't exist. And that's because I forgot this directory index. Alright. Whoops. Honestly, I don't know whether this is the same error. Let me just stop this. Why do I have such high GPU RAM still? Okay, I'm just gonna click stop. I'm gonna go ahead and flush this. Do the run again. Seems to be an issue. Okay, I'm gonna go ahead and stop this, but also what I'm gonna do is use a completely different computer environment. Even though I did V100, I didn't do the high RAM. Let's see if we can get A100, which automatically has high RAM. Okay, here it is. Okay, so the downside is we have to kind of do a lot of things again, but it's like fine because we already did our research, so it's just going to be quick. I'll be right back while this happens. Okay, I'm back, and we are going to copy that payload from drive, my drive, X, to here. Make dir, make dir accurate. Alright, and I'm just going to actually, I'm going to RM index. Because it's already going to make a directory, so I don't think that's necessary. Unzip index as it. Okay. If we cd into our index, you know, while this is occurring, I'm just going to run all of the cells, but okay. Alright, so we're already in the index directory. I'm just going to make a directory called processed. And then copy the one that's resized into processed. So go into that directory. Let's see if it's there. Make another one. My directory, name outputs. So we right now just waiting for everything to get set up. It's gonna take a little moment, so hasn't really started installing things, just really downloading them. Have a lot more RAM and GPU RAM. I think what happened before was I forgot to put high RAM on my V100, and that's why that happened. Because before, when I tried to use the V100, it had set the high RAM as default. I think mainly because that's just due to availability. But the A100 did give me one. Sometimes it doesn't give me one, and it did give the high RAM version. So this is a little bit more expensive, even more expensive, but I'm hoping that you know, we can do this. Okay, great. So I was able to download or install that. Um, Downloaded, loading the model. I think this is where we can see, yeah, the GPU jump. We also saw the GPU jump 10 gigs in memory before, so this is expected. Okay, so it was able to run the sampling function too, and great. Okay, I'm just gonna put 3. And we have our content / index / processed. Yep. Cannot identify image file. Okay. I'm not sure why that's happening. What if I don't have a slash? Okay. So this is probably because I didn't restart it. It's told me to restart the session. So over there in the setup, I'm gonna rerun some of this. Download the weights, load the model, sampling function, and then execution. Should be significantly faster than before, but spike is where floating those neural weights. Okay. So let's do the run. Okay, I think that's the directory. Yep, content index processed, and then we're going to do 3. You can see some of these stuff is a little more faster, but half an hour later, we are testing this code out, and I just need to make sure that it is making the samples correctly. So I can have like a good understanding in a few minutes, and then after that I'll take a break, come back when it's done computing, and then share results. Alright, I'm on terminal. Just gonna see ins outputs. Alright. is able to do it. Let's see. So for one, that took about 1 minute, you could say. So you have about 50 images. Each image we're processing 3 times at 1 minute each. So 150 images, it will take about 150 minutes, which is just about a little more than 2 hours. I will take a look to see whether it's able to output correctly. I will end the stream if it does, but let's hope it does. The stream's going on for 4 hours. So, okay, it has. So we fixed that error. And that is great. Okay, so we're going to have to basically wait for another 2 hours for it to completely be done, but I will share results after that. I don't think people want to see me wait until it ends. So thank you, everyone. I think I got a total of 7 viewers, and that's more than 0, so that's success. Thanks, everyone. I'll be live streaming again to share the results, but for this, we are done. Thanks.